Hi everyone, welcome back. Today we're talking about bigger and better graphs of sine and cosine. Right here we have our parent graphs of our sine and our cosine function, and we really need to hammer in this vocabulary so we're all speaking the same language. In our top graph we have 2 periods of the sine function. So we need to understand what a period is. So both of these functions are actually periodic, which means that the graph has a repeating pattern. The shortest repeating pattern of the graph is actually called a cycle, and that the horizontal length of each of the cycles is what we call a period. So the length from 0 all the way to 2 pi is our period. And you'll see that each of the repeating patterns all have periods of 2 pi. We also have our maximum and minimum values that we've chatted about in the past. For our sine function, we've got maximum values, local maximum values of 1 and minimum values of -1. And we chatted a little bit about our amplitude, which the amplitude of the graph is just like half of the distance from the maximum value to the minimum value. So half of that distance, that total distance would be 2, and then you take half of it, and there you have your amplitude of 1. I kind of look at your midline, and I go from my midline, how tall is that? So you've got a distance of 1. So feel free to do that if you would like. You've got your range for your y values is between -1, your minimum, up until your maximum value of 1. So you need to make sure you keep that in mind as we go into trig identities, that your range of sine and your range of your cosine is actually the same. It's only y values between -1 and +1. And that pretty much wraps it up. So your period for cosine is still 2 pi. So from 0 all the way to 2 pi is that length of one cycle. And this little core concept outlines everything for you. They get into our x-intercepts for each of the functions, and you'll see that there are definite patterns for your x-intercepts. So for your sine function, you've got x-intercepts of 0, plus or minus pi, plus or minus 2 pi, plus or minus 3 pi, so on and so forth. And then your x-intercepts for your cosine are on increments of pi over 2, so plus or minus pi over 2, plus or minus 3 pi over 2, and so on and so forth. Now, of course, we can transform these graphs, we can stretch, and we can shrink our sine and cosine functions. Hopefully, from the investigation yesterday, you have a general idea of what I'm talking about right now. So when you have sine function and you have an a value being multiplied by the sine function, that is your vertical stretch and shrink of the graph. And this is the same across all of our functions that we've dealt with all year. And then if you have a b on the inside of your sine and your cosine function, those are, of course, your horizontal stretch and shrink by a factor of the reciprocal of that b. So when you look at your for your A and your B, what is being affected here? It's your amplitude and your period. So your amplitude is actually the absolute value of whatever that A value is. And your period, the old 2 pi, can either get stretched or shrunk depending on what the B value is. So your period is 2 pi divided by the absolute value of the B. All right, so my suggestion is to get your Fab 5 points. So in this case, they call it the 5 key points of each of the functions. Let's get into an example. So in example 1, we need to identify the amplitude and the period of g of x, which is 5 sine of x. And then we're going to graph the function and describe the graph of g as a transformation of our parent function of f of x equals sine of x. I take a look here. I look and see which function is it. It's a sine function. So I listed out my parent function for sine, and that's your 0, 0, pi over 2, 1, pi, 0, 3 pi over 2, negative 1, and 2 pi of 0. We can take a look at our g of x, and you see a 5 being multiplied by the sine function, and that is our a value. So our amplitude is the absolute value of that a value, which is 5. Our period, there's no number being multiplied inside with the x, so our period stays as 2 pi, which technically our b value would be 1, so it's 2 pi divided by 1, but no big deal. Our period hasn't changed. And I'm going to get my intercepts and my maximum after I graph it. So let's go and graph our parent function. We've got 0, 0, pi over 2 is at 1, so I'll go 1 and negative 1, and pi is 0, 3 pi over 2, negative 1, and 2 pi. So here's one period of my sine parent graph, so I'll call that f of x, so that our done graph we can compare. For our g of x, our 5 sine of x, I'll change colors and blue will be done. Our amplitude now needs to become 5. So we're going to have a max and a min of 5 and negative 5. And our 0, 0 will stay there, but our pi over 2 will get stretched up. So everything's being pulled up away from the x-axis or down. So pi stays there. 3 pi over 2 goes down to negative 5. And 2 pi stays on the axis. So in our vertical stretch and actually vertical compression, our x-intercepts will stay, but our maximum and minimum values get pulled. All right. So that's just one period of g of x, and I like to do 2 periods. So back trail, you'll have negative pi over 2 down at negative 5. Negative pi will be your intercept, and negative 3 pi over 2 will be a height of 5, and back down to negative 2 pi. So in blue, you've got 2 periods, which is sufficient as long as you put arrowheads at either end, because you know it's periodic and it repeats itself forever and always. So your intercepts are 0, plus or minus pi, plus or minus 2 pi, and so on and so forth. So increments of pi. Our maximum is 5 and negative 5. I separated it. So our maximum is 5, and our minimum is negative 5. For example 3, we're going to identify the amplitude and period of g of x, which is 3 cosine of pi x. Then we'll graph the function and describe the graph as a transformation of your parent graph of cosine. All right, so we have an a value of 3, and it's safe to assume that pi times x is inside of the argument of the cosine, so our b value is equal to pi. All right, so our amplitude of this function would be 3. Our period gets changed because of that b value. So you have a little formula of 2 pi divided by absolute value of b. So 2 pi divided by that pi, it's actually that because of that pi, you're actually compressing the graph from 2 pi down to 2. All right, we'll deal with our x-intercepts and our max and min after we get our graph. So how do I graph this with a period change? Well, I'm going to scoot this up a little bit. I'm going to take a look. My amplitude has to get to 3 and negative 3. So 3, here's negative 3. So label your y-axis according to your amplitude. And then your period, what I usually do is I go all the way, like nice increments for my period. So my period is 2, so I'm going to label my x-axis as maybe 1 here, 2 here, 3, 4, and back trail -1, -2, -3, and -4. Now, remember our cosine. One period looks like it starts high, hits the x-axis, goes low, hits the x-axis, and then goes high again. So, I mean, in a ghetto way, that's one period of your cosine's parent graph. So we're going to stretch that parent graph, and we're actually going to compress the period. All right, so I'm going to do that all in one full swoop. We have at 0, you would be up at 3. So starts high. And then what I do is I go, here's one period of our function. I'm going to divide that into 4 pieces. So 2 divided by 2 is 1, right? And then take the distance from 0 to 1 and cut that in half again, 1/2. And then the distance between 1 and 2 would be 3/2. Okay, now our Fab 5 points lie along those x values. So if it starts high, we're going to hit our x-axis at 1/2 and then goes low to -1 to -3. And then it's going to hit our x-axis at 3/2 and then one full cycle complete, whoops, at 2 would be back up at 3. So here we go. Here's one period of our function. Now, it is periodic, so make sure you graph more pieces. Okay, so we're going to go back down. Here's more to the graph, and I usually just make it go off of my graph paper, and then I'll go backwards. I'll just put dots so I can just connect the dots. All right. So in purple, you have one period, and then the pink is just a repeating of that period. All right. And let's take a look at our x-intercepts. So our x-intercepts are at 1/2, 3/2. Increments of all of those. So it would be at plus or minus 1/2, plus or minus 3/2. Keep going, plus or minus. We've got 3/2 and then 5/2, plus or minus 7/2. And I mean, you can go at that point, keep going. Our max value is 3, our minimum value is -3, and that pretty much completes our graph for that. We move into translating sine and cosine functions. So think back to every other function that you're talking about this year, and you're going to see translation. You're going to see numbers being added or subtracted inside of your function, and added or subtracted on the outside of your function. All right, this would be called, if you have a horizontal translation of any period function, you're going to call that a phase shift. So when you pick up the graph and you move it to the right or to the left, you're actually causing a phase shift. So to graph your functions, here's your general forms that we're building up to for sine and cosine. All right, so here's your steps. You're going to first identify the amplitude, and then you're going to identify the period, 2 pi over b, and then you're going to look for the horizontal shift to the right or to the left, and then look at your vertical shift up or down. Drawing the midline through the graph is going to be definitely beneficial, and I'll show you what to do. And we're going to take our 5 key points by translating the key points from our parent functions or versions of our parent functions and draw the graph. All right, it's a lot, It gets pretty involved, but you can handle it. All right? You can do it. So we're going to graph g of x, which is 3 sine of 2x plus 5. Take a look. Let's find our a value. We've got our a value of 3, so our amplitude is 3. Our period has been changed because we have a b value. So b is equal to 2, so let's find our period. Our period went from 2 pi for sine and got divided by the 2, and so your period got shrunk to just pi. And we also have a up 5. Okay, that 5 is being added on the outside of the function, so that's your shift up and down. All right, let's see what we can do here. Let's give it a graph. So I'm going to first graph ignoring the plus 5. So I labeled my x-axis according to my period. So here's my period of pi. My amplitude is labeled my y-axis is labeled according to my amplitude. So I can get one period of, let's go, I don't know, like f of x is equal to 3 sine of 2x. So I'm going to ignore the up 5 and deal with that last. So take that period of pi, cut it in half, you get pi over 2. Now cut that again in half and you get pi over 4. And cut from pi over 2 to pi to be 3 pi over 4. And that'll help with your Fab 5 points. So we have, let's see, it's a sine function. So remember, sine functions start at 0, 0, they go up, back to the x-axis, they go down, and back to the x-axis. So it'll be like this, one period of sine. All right, so starting at 0, 0, we stay there. And then our amplitude got changed to be 3. So go all the way up to 3 for your next point at pi over 4, and then back to the x-axis at pi over 2, down to -3 for 3 pi over 4, and back to the x-axis. So this is your horizontal shrink, technically, and a vertical stretch of a factor of 3. All right, now we're going to take that one period and go up 5 with it. So I'll go in blue. So take all of your points, and actually your midline goes with it. So I personally like to draw my midline where my midline was before the x-axis. It's going to go up to 5. So draw your midline, and that usually makes your life a little bit easier. And it looks like it's going to go off my graph, but you'll see. I think you'll get the general idea. So take 0, 0 and go up 5. So it'll sit on that midline. Your next point goes up to 5. So maybe I should extend this a little bit. Sorry, guys. So 7 and 8. Kind of ghetto, but oh well. Oh, okay, so 0, 0. And then 3 goes up to 8. At pi over 2 goes up 5. 3 pi over 4 goes up 5 down here. And pi goes up to 5. All right, so here is one period of your done graph. Now we're just going to extend it. And I like to change colors so you can see my parent graph and where it went. So let's see. Just keep that pattern going. I think I missed it. There we go. Here. Oh, I'm gonna touch the other graph. Oh no. It's okay. All right. So I think you guys get the idea of that, hopefully. You can describe your x-intercepts and period and phase shift. Well, we don't have a phase shift. Let me just finish my graph. So I'm down at here. All right, and so on and so forth. Oh, it's getting ugly. All right, so I'm going to draw some arrowheads. I don't want to waste your time. All right, so our midline got changed. Do we even have any x-intercepts? No, our graph no longer hits the x-axis. So put none. Our maximum is 8. Our minimum is -8. And that's a wrap for that graph. Moving on. A few more examples, all right? We've got a cosine example. All right, so remember what a cosine parent graph looks like. It starts high and then goes low. So we've got our a value of this function is 2. We have our b value already factored out, okay? If you don't have that b value factored out of your argument, you need to make sure you write it in this form, and then you'll see your right pi. All right, so amplitude is 2, period, 2 pi divided by 1/4 is really just 2 pi times 4, which is 8 pi. So this is actually a horizontal stretch, okay? Your period got stretched out to 8 pi. And we'll deal with our intercepts and our max and min after we get our graph. All right, so I'm going to go and I'm going to label my axes. I've got a amplitude of 2, so I'll go a 1 and a 2, 3, 4, -1, -2, -3, and then I'll label my x-axis according to my period. So I have to get all the way out to 8 pi. All right, so 8 pi from 0 to 8 pi will be 1 period. So half of that would be 4 pi. Half of 4 pi would be 2 pi. And then between 4 pi and 8 pi would lie 6 pi. So pretty much if I wanted to graph like f of x before any right movement, I would be getting 2 cosine of 1/4 of x would be just this graph. So starting 0, 0, oh, no, cosine, sorry about that. Cosine starts high, so an amplitude of 2. I'm going to start high, get to my x-axis, go low, get back to my x-axis, and go back up. So here is my green graph, which is f of x, 1 period of f of x. And now we can pick this up and we're going to move it to the right pi. So we're actually phase shifting this. We're shifting it to the right or to the left. So everything goes to the right pi. So maybe I even want to label like between. Here's your 3 pi, 5 pi, 7 pi. Whoa. So shift everything to the right pi. So phase shift of pi to the right pi, to the right pi, to the right pi, right pi, and right pi. All right, give it a graph. Dang, I keep hitting that. Sorry, guys. All right, so here's 1 period, and I'll just extend that to B. I'll change it to, what was I in? Let's do purple. So we'll put arrowheads over here, and I'll continue backwards. So we would touch my x-axis here, keep going. Up to 2. All right, and shoot it off in that direction. All right, so let's talk about our intercepts. Now looking at the blue/purple graph, you've got x-intercepts of, let's see, 3 pi, 7 pi. And then back here, that's not negative 3 pi. Let's go back and figure that out. That would be a negative pi, negative 2 pi, negative 3 pi, negative 4 pi, negative 5 pi, and so on and so forth. So we've got 3 pi, 7 pi, and keep going. And also negative pi, negative 5 pi. So really multiples of 4 in either direction. You've got a maximum of 2 and a minimum of 2. All right, and our last transformation that we talk about for our sine and cosine function is just reflections across your x-axis. So to reflect a sine and cosine, you're going to see a negative with your a value. So negative sine of x is just a reflection of our parent function of the sine, and it gets reflected across your x-axis. So everything that was up flips down, what was down gets flipped up. And same story with your cosine. All right, so this is as bad as they get. After this, we are done, so hang in there. We have a bunch of transformations happening in this function. You've got one, identify that it's a sine function, and we see that your a is 3. So a is 3. We've got a reflection across your x-axis with that negative sign. We have a pi over 2 as our b value, so we know our period is going to change. And then, last but not least, you've got a right pi. Okay, let's take one thing at a time. So we know our amplitude is our a value. So absolute value of the a value, which is 3. Our period goes from 2 pi and gets divided by your b value of 1/2. So really that's technically 2 pi times 2, which is 4 pi. And we'll deal with our x-intercepts later. So let's get that. I'm going to first graph, let's see. Let's first graph, like, call f of x 3 sine of 1/2 of x, and then we'll reflect it across the x-axis, and then we'll take it to the right pi. I think that's our easiest course of action here. So I have my x-axis labeled according to my period. So my period goes all the way out to 4 pi, and then I took half of that to get 2 pi, and then half a half is pi, and you have 3 pi in between your 2 pi and 4 pi. So our 3 times sine of 1/2 of x would look like, got amplitude of 3, and it's a sine function, so we know it starts at 0, 0, goes high, goes back to your x-axis, goes low, and 4 pi. So here is your f of x, one period of it. And now we're going to pick it up and we're going to reflect it across. I'll go green. Green will be negative 3 sine of 1/2 of x. So reflect it across your x-axis. 0, 0 will stay there. At pi, we'll go down to negative 3. 2 pi stays there. 3 pi gets flipped up. And 4 pi stays there. All right, we're almost there, guys. And last but not least, we're going to take it and we're going to move our green graph. I'm going to erase my purple one just so things don't get too crazy. We're going to take our green graph and we're going to shift him to the right pi. All right, so let's call that, let's go pink. Will be our done graph. So take everything to the right pi. So that would be the function, our done function g of x is equal to -3 sine of 1/2 of x minus pi. All right, so right pi, everything goes right, oops, right, and I'll put it over here just so. Here you go, one period of it, and then we just slap some arrowheads on it and back trail. All right, looks pretty nice. Have my arrowheads. Now we can talk about our intercepts. Let's take a look at our intercepts. We've got pi, we've got 3 pi, we've got negative pi, we've got negative 3 pi. So our intercepts will be plus or minus pi, plus or minus 3 pi, so on and so forth. Dot, 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 dot. Our maximum will be 3. Our minimum will be -3. And that is done and done. All right, we survived, you guys. Hopefully you guys understand this, and if you don't, let us